Hi, my name is Yasin Zarwal. I will guide you in this lesson, which is a lesson from the CCNP Routing and Switching course. Lesson 2, using EIGRP authentication for security. Controlling neighborships using EIGRP authentication. EIGRP authentication causes routers to authenticate every EIGRP message. To do so, the routers should use the same pre-shared key, generating an MD5 digest for each EIGRP message based on the pre-shared key. If a router configured for EIGRP authentication receives an EIGRP message and the message's MD5 digest does not pass the authentication check-in based on the local copy of the key, the router silently discards the message. As a result, when authentication fails, two routers cannot become EIGRP neighbors because they ignore the EIGRP hello messages. Using EIGRP authentication. From a design perspective, EIGRP authentication helps prevent denial of service attacks, but it does not provide any privacy. The EIGRP messages can be read by the device that physically receives the bits. Note that on LANs, the updates flow to the multicast IP address, which is 224.0.0.10, so any attacker could join the 224.0.0.10 multicast group and read the packets. However, authentication prevents attackers from forming neighborships with legitimate routers, preventing the advertisement of incorrect routing information. EIGRP authentication configuration checklist. The EIGRP authentication configuration process requires several commands, which are summarized as follows. Step 1. Create an authentication keychain. Create the chain and give it a name with the keychain name. In global command, create one or more key numbers using the key number in command in keychain configuration mode. Define the authentication keys value using the key-string value command in key configuration mode. The key strings must match on the neighboring routers. Optionally, you can define the lifetime time period for both sending and accepting each key string. Step 2. Enable EIGRP MD5 authentication on an interface for a particular EIGRP autonomous system number using the IP authentication mode EIGRP autonomous system number MD5 in interface subcommand. Step 3. Refer to the correct keychain to be used on an interface using IP authentication keychain EIGRP autonomous system number name of chain in interface subcommand. Lab. I did this network using GNS3. Here we have 4 routers, R1, R2, R3, and R4. We will configure EIGRP authentication on the routers R1, R2, R3. Before doing that, let's see the EIGRP neighbor relationship for each router. Here, R1 has 2 EIGRP neighbors, R2 and R3. R2 has 2 EIGRP neighbors, R1 and R3. And R3 has 2 EIGRP neighbors, R1 and R2. Now we will start the configuration of EIGRP authentication on R1. First, create keychain. The keychain does not have too much on the neighboring router. Key string, which is a secret key, it must match on the neighboring routers. So we'll go to interface serial 0/0. autonomous system number 10. You see that R1 lost its neighbor in this interface. Now I will go to interface serial 0/1 to do the same command. The same thing happened here. Also R1 lost its neighbor in this interface, which is interface serial 0/1. I will go to R2 to do the same configuration. First create keychain. I will go to interface serial 0/0. Autonomous system number 10, MD5. I will go to interface serial 0/1. Do the same configuration. Now it's okay with R2. I will switch to R3 to do the same configuration. First create keychain. We did the configuration. Now we will check the EIGRP neighbor relationship for each router, for example R3. After doing the EIGRP configuration, EIGRP authentication configuration, now R3 form two EIGRP neighbors, which are R1 and R2. R2 also form two EIGRP neighbors, which are R1 and R3. And R1 also form two EIGRP neighbors, which are R2 and R3. Now, if we disable the EIGRP authentication on interface serial 0/0 on R2, you see that R2 will lose its EIGRP neighbor relationship with R1. Now let's go to R2. Before disabling the EIGRP authentication on interface serial 0/0, we need to enable debug EIGRP packets on R1 to see the details, to see what happened. Now I did enable the debug EIGRP packets on R1, and immediately now I will disable the EIGRP authentication on interface serial 0/0 on R2, and you can see that R1 we have here authentication fail, we have missing authentication failure, authentication failure. At the end of the lesson, and in a nutshell, the goal of using EIGRP authentication is to control the EIGRP neighbor relationship and also for security. Thank you very much for your viewing.